Hey guys, welcome back. This video we're looking at polynomial values, and where this one is fairly straightforward. If you are familiar with substitution and substituting values into prime or variables, then that's basically what we're doing here. But we're going to make it just a little bit trickier by substituting not only just numbers but some variables as well. So let's just say we had a polynomial of 2x cubed plus x squared minus 3x minus 4. So that's what we'll call the polynomial function of p of x. Okay, but let's say we want to substitute each value with a 1. Okay, so anything that has an x, we're going to replace it with a 1. So that means it's 2 times 1 cubed plus 1 squared minus 3 times 1 minus 4. Okay, and so we've got 2 plus 1 minus 3 minus 4. And then if we add it all up, we can see that the 2 plus 1 cancels out with the minus 3. You're left with minus 4 as your answer. So here's your polynomial function, p of x, but then the polynomial value of 1 is going to then leave it with minus 4. Okay, simple as that. But let's say if we change that with a negative, it's no different. You just need to make sure that you are careful with your polarities. So 2 times minus 2 cubed plus minus 2 squared minus 3 times minus 2 minus 4. Okay, so minus 2 cubed is going to be minus 8. So minus 8 times 2 is minus 16. Then minus 2 squared is 4. Minus 3 times minus 2 is positive 6 and minus 4. So what we'll have is, we can see the 4's cancel out, and so we're left with minus 10. Okay, let's ramp it up to something that has variables. Okay, and again, you can see how we're substituting. Things don't really change. But what happens if we say p of a? So basically, you're replacing all the x's with an a. So it'll be 2a cubed plus a squared minus 3a minus 4. There's really nothing else that you need to do further than that because it's got it's just a variable. We're just replacing the x with an a. There's no numbers. But if we had something like, let's just clear this up. If we had p of 2b, then we're going to do the same thing. So 2 times 2b cubed plus 2b squared minus 3 times 2b minus 4. So now we're not only replacing with another polynomial, but we're also including a value. So you want to make sure that you apply the powers to those things. So what we'll have is 2 cubed is 8. So 8b cubed times 2 is going to give us 16b cubed. Okay, and then 2 squared is, and then 2 squared b squared. So you're going to have 4b squared. And then minus 3 times 2b is going to give us minus 6b. And then we have minus 4. We have nothing left here to simplify or put together. That is simply going to be your answer. I'm going to finish off with one more example where we're going to substitute it with something a little bit more substantial. It will take you a little bit longer because there's just a lot of expansion involved. Okay, so what would happen if we decide to, say, replace each x with an x plus 1? Nothing different to what we've done before, but obviously we can already predict that this is going to be a very long, drawn-out process. So 2 times x plus 1 all cubed plus x plus 1 all squared minus 3 times x plus 1 minus 4. Okay, so I'm going to work from the right back to the left just to show you that it is, no, actually I'll just go from the beginning. So we've got x plus 1 times x plus 1 times x plus 1, okay, and we've got a 2 in the front. Now, because we got perfect square here, we can already assume that's x squared plus 2x plus 1, okay, and then we're going to multiply that plus by x plus 1. I'm going to keep the 2 there, and I'm going to expand this set of brackets here. We got x cubed plus 2x squared plus x squared plus 2x plus 1. And because we still have the 2 in front, we're going to have 2x cubed plus, let's actually, before we do that, I'd like to combine like terms. So we got 3x squared, and then we have plus 3x plus 1. And we're going to multiply that by 2. So 2x squared plus 6x squared, sorry, x cubed. See, this is thing. I'm trying to speed it up too fast, and I'm making really simple mistakes here. So it's really important that you don't leave them out. Okay, so 2x cubed plus 6x, and then 6x squared plus 6x plus 2. And that's only for this portion here. So I'm now going to expand this one, and we can already see that this in the purple is going to be x squared plus 2x plus 1 because it's a perfect square. So we can easily add that to the end. And then lastly, expand that bracket is minus 3x minus 3. And then we're going to finish off with putting the minus 4 in the end. Okay, so now that you've got all of that, we're going to simplify everything and put combine like terms. So do we have any other cubed? No, we don't. So 2x cubed remains as is. We have a 6x squared plus an x squared. So that's going to be 7x squared. Then we have a 6x plus a 2x minus a 3x. So 6 plus 2 is 8, minus 3 is 5x. And then we have a 2, a 1, a minus 3, and a minus 4. So 2 plus 1 is 3, minus 3 cancels out, and so you're left with minus 4. So what we have is that as our answer. When we substitute x with x plus 1, we have 2x cubed plus 7x squared plus 5x minus 4. I've written every single step down so I keep track with everything and I don't lose my place. Please take your time with this and don't rush it. If you have any questions about polynomial values, let me know. Otherwise, see you in the next one.